Economic dispatch is the determination of the optimal output scenario of a number of power plants to meet the system load at the lowest possible cost, subject to transmission and operational constraints. Hello everyone, my name is Rafael. I'm an electrical engineer, and in this video I would like to invite you for a conversation about the economic dispatch of power plants. And to do so, I chose this exercise. I am going to read the exercise and show you step by step the solution. Let's go! The figure shows an electric power system composed of two generators and one load. The fuel costs of generators G1 and G2 are: the fuel costs of generator 1, $140 per megawatt hour, and the fuel costs of generator 2 is $170 per megawatt hour. And the line losses are 0.5 times the output power of generator 1 squared, where the loss coefficient is specified in per unit on a 100 MVA base. The question: calculate the most economic power generation dispatch in megawatts. Okay, my friends, this is the question. Now let's go to the solution. All right, let's begin this calculation by finding the penalty factor of generator 1. The penalty factor of generator 1 is going to be it is 1 divided by 1 minus the partial derivative of the losses divided by PG1. And since P loss is equal to 0.5 times PG1 squared, this partial derivative here is going to be (0.5) times 2 times PG1, which is equal to PG1. Okay? Then this expression becomes 1 divided by 1 minus PG1. L1 is equal to 1 minus PG1. Okay? Now let's calculate the same for generator 2. This is for generator 1 and this is going to be for generator 2. The penalty factor for generator 2 is going to be (1 divided by 1 minus the partial derivative of the loss over with respect to PD2, okay? The partial derivative of the loss with respect to PG2. And since And since this is 0, okay, and since this is 0, this expression here becomes all right. Up to this point, we have calculated the penalty factor for generator 1 and the penalty factor for generator 2. For the most economical dispatch of power, C1 times L1 is equal to C2 times L2, okay? The operating cost of generator 1 times the penalty factor of generator 1 is equal to the operating cost of generator 2 times the penalty factor of generator 2. Then 140 1 over 1 minus PG1 is equal to 170. This comes from this comes from this, L2 is 1 and L1 is this, okay? Which gives PG1 equal to 0.1765 PU. And since the base apparent power is 100 MVA, this is a given of the problem. PG1 is equal to this number here, okay, this number here in per unit times 100 MVA, and this is 17.65 megawatts. All right. Now let's calculate the rest. The loss in transmission is going to be P loss, which is 0.5, okay, times this expression was given by the problem, okay, 0.1765 squared, okay. The loss was given by the problem as 0.5 times the output power of generator 1 squared, which is equal to 0.0156 per unit. And if we multiply this in per unit by the base apparent power, which is 100 MVA, we get 1.56 megawatts, okay? Thus, the actual power supplied by generator 1 to the load, okay, to the load. This is the power that generator 1 supplies the entire system, but there are losses. the actual power generator 1 supplies to the load is then 17.65 megawatts minus 1.56 megawatts, which is equal to 16.1 megawatts. This is the fraction of the power supplied by generator 1 that actually goes to the load. The rest is lost in transmission. Now, let's calculate the power supplied by generator 2. The power supplied by generator 2, I'm going to show you just a minute. The power supplied by generator 2 is going to be 40 PD2 is going to be 40 megawatts, the power that the load requires, minus this, okay, the power from generator 1 that gets to the load, that actually reaches the load. 16.1 megawatts, which is equal to 23.9 megawatts. Okay, my friends, this is the video that I wanted to make to show you the economic dispatch of power plants. I hope you liked it and learned from it. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye!